Okay, hopefully this is all working. This is the first time I'm trying to multi-stream, so we should be live on Twitch and YouTube, which may save me some time later, because of course it'll all be up on YouTube as soon as we finish. Okay, DevOps for beginners. So where had we got to? If you've been following along, then you should be now on the Lab 4 touch point. I've got a virtual machine here which has been created, and in that virtual machine you should find that you've got this Scratch directory, and in there we've got a basic pipeline set up, and if we go back to the Vagrant file, I've made a couple of small changes in between the end of the last session and this one. The first thing I've done is I've got this Bootstrap project shell script, which is a fairly simple beast. What this does is it gets the repository which has got this Scratch source project in it, and then it invokes this initialize pipeline script, which is just nope, not pipeline, which all the initialization thing does is it sets this pipeline up, which is the pipeline we set up last week, and then it unpauses it. The upshot of all that is that over here we've got this pipeline running, which is about as simple as it gets, which basically has one resource, which is the source of the repository, which is actually this Scratch project, and it has this one job, and the job is the build job, and the build job consists of two tasks, make and unit, where make actually runs the Sphinx utility to build the website, and then we run some link checks. And what link checks does is it just makes sure that any external links on our website are actually valid. So it's the very simplest of shakedown tests. Now, the problem we've got now is this project really doesn't contain anything. It just contains the initial sources, which means that when we run the build, it just builds a very basic website, but we've got no real way of interacting with that website at the moment because we've not deployed it anywhere. And that was what I intended to look into this week. So the question is, where do we deploy it? Well, before we go on to that, let's take a look at one of the issues we've got. When you're developing these things, you'll notice if you look at the log, online like that. This is where you get, there we go, one line. Okay, so you can see here we've got lots of very small commits. Okay, so you're adding the unit tests, adding the script, And then we've got these like, typos here. And this was because in order to test the task, I was actually committing stuff into the remote repository so that this pipeline was kicked off. Okay, so this doc site would change and that would cause this build to happen. And that was the way I was testing it. And that's fine. But what it means is that you end up soiling your commit history with loads of stupid little things like these typos. So what we want really is a way of testing these scripts, the tasks, the elements of the build, without actually having to push them through a pipeline. And we can do that in Concourse. It's a fairly straightforward process. And the way we do it is we use the fly interface like we would do with everything else. Okay, so we specify the target, and the target we're going to specify is main. This is the one that we're using. If you go up here, this fly login up here actually sets up the main target. And then we say we want to execute. And then we want to say what we want to execute. Well, what we want to execute is this in this Scratch directory, the CI tasks, and let's say we want to do the build. We've got the build file that we created, and then we can specify the inputs. Now we can specify the inputs as actual directories. Okay, so DocSite is one of the inputs to the Sphinx build project, and what we actually want to input for DocSite is this Scratch directory. Okay, and it helps if you actually spell things correctly. Oh. Okay, and the other thing we want to specify is the output. And I'll explain these in a second. If you were watching last week, this should be fairly familiar. Okay, so the doc.html is where our output of our build is going to be written to. Okay, and we're going to set that to be vagrant slash, let's do it vagrant slash site. Okay, this is going to write that into the vagrant site directory. So what this is doing is it's executing the build and supplying the inputs and the outputs as being actual directories. So we're no longer going through the pipeline. We're actually executing the build as is in place. Okay, so let's take a look at that. The build is this build here. Okay, so this build file is the configuration of the task that we're going to actually run. And these are the inputs and the outputs that we've just specified. Okay, so these are the inputs and the outputs to the task. Okay, and then what you do is you run the actual script in that context. Okay, so if we look at the script, okay, it's a very simple beast. All it does is it says, okay, I've got these two directories, DocSite and doc.html, which are the inputs and the outputs. Okay, and then I run this make command and I specify the doc.html as being the build directory, the destination, and I say I want to build the HTML. Which means it's going to build a website. Okay, so if I now look at the output of that, If you remember, we put that into this site directory. Okay, this is what has been created as a consequence. Okay, now that's actually on my host machine because I wrote it out to the Vagrant directory, which is mapped. Again, if you've been following along from the first labs, you'll know that /vagrant is mapped to the directory in which the Vagrant file sits. So if I actually okay, so you can see here, this is the place where the Vagrant file sits. That's the site directory that we've just created as part of this build. Now what this allows us to do then is take that site directory and pass it on to the next task. Okay, so if I actually look at the pipeline, okay, the pipeline says, okay, take the task make, which is the one we just run, the Sphinx build. Then I want you to run the task unit, which is the next thing in the line. Okay, so if we look at this build over here, okay, this make here is this task, right? And this unit is this unit here. Now, ordinarily, the inputs and outputs of this task would be chained together like they are here, right? Where this make is producing something into doc.html, and that doc.html is being passed as input into the unit task. Okay, so if I actually look at Sphinx unit, you can see here that that takes inputs docsite and doc.html. You'll notice that at the moment it produces no output. We're going to fix that. Because assuming that this is successful, what we want it to actually produce is the package of the website that we're building. Okay, and this is the script that's actually run. You'll notice this is actually in the doc site. It's passed in as part of the parameters. So if I go to script Sphinx unit, okay, it's very similar to the other one. We take the two directories which we get as inputs. Oops. Okay, so these two inputs here. Okay. And all we do is we run the make, but this time we're running the make link check. Okay, and that's just going to succeed or fail. It will succeed if there are no external links on our website that are broken, in other words, don't work. Right, that was all. Probably very confusing. Let's see if we can make it a bit clearer. Right, so to cover all that again, but this time with pictures. What we've got is so the pipeline is defined within Concourse, and that consists of jobs, which in turn consists of tasks. Okay, so we can see the pipeline okay, so you can see the pipeline here. We've got the jobs, of which there's one. Okay, and that's the one that's called build. And that appears on our pipeline here. Okay, so that's just the build. And you can see that it has one resource associated with it. Okay, which it takes as an input. Okay, and that's defined up here, and it's just a git resource, and it tells us where to get it from. Okay, and that's this black box over here, doc site. So at the moment, we've got one pipeline called the Sphinx pipeline, which contains one job, which is called build. And within that build, we've got two tasks which run in sequence. One make, one called unit. Okay, and they just run one after the other. And make runs a script called Sphinx build. Actually, I'll rephrase that. It uses a task file called Sphinx build YAML. And the other one uses one called Sphinx unit.yaml. And those two files, those two YAML files, describe the tasks. Okay, so in the case of Sphinx build, in the case of Sphinx build, it takes one input, okay, called doc-site, and it produces one output called doc.html, and it then runs this script called sphinxbuild.sh. Okay, so we've got one input called doc-site, okay, which then gets put into a script called Sphinx build.sh, and that produces one output called doc.html. Then that doc.html actually becomes the input to this Sphinx unit test. Okay, so if we now go up to here, so you can see here that we've got two inputs, docsite and doc.html, which get fed into the single script Sphinx unit. Okay. So this time we've got two inputs going in, one called docsite, which is the same docsite as we had up here, and doc.html, and those two get fed into Sphinx init.sh. Okay, and that produces no output because all it's doing is the link check. Okay, so you can see how we're passing information around by using these inputs and outputs. Now, what you can't do is you can't pass things between jobs like this. Okay, you can't just simply, use these named directories to pass information between jobs. What you have to do is you have to use resources within the pipeline. So if we want to pass this thing into an environment, the best thing for us to do is to take the output that we've generated so far, the product, if you like, create that into a package of some description, and then put that into an artifact repository where we can say, okay, this is version 1 of our product. And from there, we can pass that into any number of jobs for deployment. Okay, so we could then pass that into an acceptance test environment or a unit or an integration test environment, and we can deploy that however many times you like. It's now a fixed point, as it were. Okay, so what we want to do is take this doc.html. Okay, so we want to take this doc.html, which you'll recall is the website that we've just produced, and we want to create some kind of package. Okay, and we want to put that package into an artifact repository. Okay, which then makes it our releasable thing. Okay, so this is the release. Okay, we've got a few things to deal with if we want to do this. There's versioning to deal with. Okay, so we need some way of versioning our builds to say this is version 1, this is version 2, and so on. Okay. The next thing we need to do is actually create some kind of artifact repository, whatever that's going to be. And there are lots of ways we could do this. We could just use some storage directory. We can use specialized artifact repositories like Artifactory, which is one, Nexus, which is again is a specialized artifact repository. We can also use things like GitHub and GitLab. They've got artifact repositories that you can use. So in order to interact with these, we need a resource type, which will allow us to interact with one of these repositories, these artifact repositories. And that means we can then create that as an output of our Sphinx unit test. Okay, and now Sphinx unit.sh, and then write to that output. And we can then do at the end of our pipeline. Okay, so this pipeline, you see at the beginning, we have this put. So down here, after we've done these unit tests, okay, we can do we can do a put down here. Okay, which means we can actually write things out. Okay, so we can actually create a repository, and we can put to that repository whatever we've produced, whatever packaging we've produced. However, before we get there, we've got a few more things to do. Okay, let's talk about something. Oh, hello. Hi, Ginger guy. This pipeline looks weird compared to a Jenkins pipeline. Pipelines are, in essence, pipelines are extremely simple beasts. Okay, I think I went through this. Okay, in essence, this is the essence of pipelines, and it doesn't matter what tool you're using. Essentially, what you've got is some sources. You're then going to put them through a series of tasks or operations. Okay, and you've and that's it really. If you're doing CI, that's the end of the story. If you're doing CD, then you're going to have a deployment task at the end, and that's it. That in essence is it. Everything else is the intermediate steps. Okay, so in Concourse, sources, we call those resources. We call the tasks are grouped together, and how you group them is up to you, into jobs. Okay, so jobs can consist of one or more tasks, and the tasks just take the inputs and turn them into outputs. That's it. Docker Swarm, we have the final project. Cool. You know what the final project is? By the way, in essence, all these modern pipeline generators, Concourse, GitHub, GitLab, are all just complicated, but they're just container orchestration systems, really. And the same goes for Jenkins. I'm talking now about the modern Jenkins. Modern Jenkins pipelines are basically container orchestration. So it's all the same. They vary slightly in terminology, but the principle's the same. Same goes for things like GitHub Actions. I mean, GitHub Actions are basically just tasks. Doing a Python and Flask application using Jenkins, GitHub, Docker Hub, and Azure, and then deploy to a Docker Swarm. Oh, okay. Yeah. I mean, I took on something relatively simple, which is really just generating a static website, but the principle's the same. Do you have to actually write the Python and Flask application using Jenkins and GitHub? I mean, Jenkins gets bad press. I don't know why. Well, I do know why. It's because it's showing its age a bit. But I mean, like I said, they're all much of a muchness. Are you actually allowed to access like open source projects and things like that, or do you actually have to write it from scratch? Okay. I take it you've got some Python chops, and have you? You've got some. I assume you're familiar with Python and Flask enough to be able to do that in whatever time they give you. I've got to admit, I've sort of pivoted to Python but I say recently. I've been playing around with it for all sorts of different things, but uh, I'm old enough to remember a time when Python wasn't even a thing. um, my back in the day, the sort of role that Python now plays used to be played by Perl. Back in the day, unfortunately, they kind of lost the plot with Perl. And it's very unfashionable now. But Python sort of filled that role. But everything we used to do with Perl is now done with Python. And I can't say that's a bad thing. Python is actually a much nicer language to use. I've got to admit, I've not done much with Flask. I mean, I've done a couple of little, toy web server things, but yeah, I've not done a huge amount with it. I tend to do command liney type stuff. Going on about learning Python, and then yeah, go. To be perfectly honest, I think from a DevOps point of view, Python is kind of the go-to. Let's call it the go-to scripting language. And I think, and that's with good reason. It's a fairly easy language to get along with. It's also a very easy language to build up a lot of technical debt. Go, on the other hand, is it's got a lot going for it. Static typing being one of the things. I think it's much more difficult to build up a huge amount of technical debt with Go. But I don't know. I know a lot of people kind of swear by Go as being sort of the next big thing. I'm not 100% convinced. I can see the merits of it, but I'd much rather people become really, really good at something like Python. I'm slightly prejudiced because a lot of the tools I use are based on Python. So, Python's a useful tool anyway. All right, first IT job, Cripes. I've got to say, if you're trying to get into DevOps as your first IT job, that's good going. What market are you in? Are you in the US or UK? Or somewhere else? UK. Oh, that's not too bad. I think the UK is much more forgiving than the US in terms of these kinds of jobs. I did discover the other day, much to my surprise, the BCS, the British Computer Society, actually have a whole apprenticeship thing going on with DevOps. I think, as with most of these things, they've over-engineered it, but oh, having your own having your own home server and stuff is, that's ideal because you can play around with stuff. The one thing I will say is that doing things on your own home system is very different from doing them in a professional environment. Just got to say that. I'm not saying it's a bad thing. It's a great thing. I screw around with stuff on my own home system. But yeah, it's different. Oh, excellent. I have mixed feelings about certificates. I think if you're just starting out, they're great. It's a bit like having a degree. Yeah. Okay, here's my position on certificate, any kind of qualification. I think they're wonderful if you're starting out, because it's the only way really of showing that you've got any chops at all. But I think coming at it from the other side of the fence, that is, as someone who is looking to recruit people, I think certificates, unless it's for a very entry level job and it's your first job, as it were, experience will count for a lot more. Yeah, absolutely. Yeah, I mean, I've got to be honest. I mean, I got a degree many years ago, late 80s, and I don't think it really. Here's what I'll say. I got a degree. It was in what was the title of it? The title was Cognitive Sciences. It was Computing and Artificial Intelligence. This is back in the late 80s, and that degree opened doors, and that's it for the first sort of 2 jobs I held. And the only reason it was 2 jobs is because the first one, the company collapsed. Actually, you say your dad worked up from forklift drivers. I mean, that's good going. My old man's the same. He was a squaddy, and ended up as well. He ended up being responsible for all the winter maintenance on the motorway system in the UK. Yeah, it's the same sort of thing. Pull yourself up with your own bootstraps, and yeah, you're right. Experience is way more valuable. But like I said, when you're starting out, you can't prove any experience when you're starting out, other than saying, "Oh, here's a project I did on my home server, or here's some open source stuff I did," and all of that's good stuff. And certificates and degrees and things like that are all useful for demonstrating, if nothing else, the ability to learn. But you will discover that after you've had your first job for 2 or 3 years, it'll be your experience that people go, yeah, absolutely. And your ability to learn, I think, is a key thing, because the one thing that's valuable, especially with DevOps, the one thing that is absolutely key is the ability to learn. You've got to be a self-starter in terms of your learning. Here's a story for you, and I'm going to be an old fart here. First time doing it, there's always so much peaceful here. I'm not sure how to take that. What was it? I was going to ramble on like an old fart for a minute there. No, the ability to learn. Yeah, it's very easy to sit back on your laurels. And back when I was a young man, I started out as a software engineer. In fact, I started out working on expert systems, which were, well, machine learning, neural networks, all that kind of stuff. And then I got a job, believe it or not, programming traffic lights. And that sounds really dull, but it's more interesting than you might imagine. But anyway, the long and the short of it is this. If I realised fairly early on in my career that I was going to end up like learning new technologies all the time. It was about the time that Java first started to hit the mainstream. In fact, I remember looking at the Java 0.8 draft specification. That was when I first saw Java. And I was coming from a Smalltalk background at the time, so it was all object-oriented stuff. And I looked at this and I thought, oh, I can see the way this is going. We had VBA, C++ back then was a preprocessor on the C compiler. It wasn't even a compiler in its own right. And I looked at that and I thought, oh, this is going to be a grind. If I stay as a software engineer, I'm just going to spend all my time learning new libraries, learning new frameworks. It's going to be a right dog's breakfast. So I got into what back then what was called configuration management, software configuration management, which now is sort of part and parcel of the DevOps engineer role. Thinking to myself, this will be relatively stable, and I won't have to keep relearning everything. And I was kind of right for 15 years. Nothing really changed. And then, then the shit hit the fan. The web became popular for a start. And more organizations moved everything into these cloud. And I was back where I started. You still have to learn all the new technology. Suddenly we were learning, containerization. You're learning about, cloud provisioning and all this kind of stuff. And all of a sudden, I was in the same situation as a DevOps as I was as a software engineer, suddenly having to learn all these new things. Hey, I tell you what. You'll never stop learning. You will never, ever stop learning. Even now, right? What was it I was looking at the other day? I was looking into, I was talking about Concourse just now, and the fact that one of the things I like about Concourse is the fact that you can run the tasks interactively. And I thought, well, can you do that with GitHub? And the answer is yes, you can. There's a third-party thing called GitHub Act, which I actually was looking at it earlier on. Yeah, GitHub Act, here we go. And this basically lets you do the same thing with GitHub Actions. You can run them locally, which means you can sort of test and debug the action locally before you actually commit it, and you end up submitting a load of bugs. Do you know what? Concourse is Concourse actually predates most of the other modern pipeline stuff. It predates GitHub Actions by about 2 years, I think. Learning computer networks. Man, computer networks. I'm actually writing a book about that. I'm writing a computer network book for DevOps people, not for computer network nerds, because network engineers have a language all their own. Sorry, I'm skipping around a bit. What was I talking about before? Always having to learn things. Yeah, you will never stop learning. Trust me, you will never stop learning everything. All the time, you'll be learning stuff. Yeah, well, like I said, if you go to work in a professional environment, you will almost certainly end up using like Travis CI, GitLab, or GitHub, their CI chains, almost certainly, which is a shame. Because, like I said, Concourse, I think, rocks. It's well worth a look. Trying to get into DevOps learning. Oh, sorry, yeah, networks. Yeah, well, again, this comes down to the you'll never stop learning bit, because networks are something that, again, I'll tell you what the problem with DevOps. The problem with DevOps is this: you need a huge breadth of knowledge, and what you find is most DevOps people, in my experience, have a huge breadth of knowledge, and then you kind of dive down into one or two specialized areas. And that's the appeal of it. I like the fact that, when you go into an organization and say, well, we've got this problem, okay, and this is the sort of day-to-day role that I ended up with it a lot. We've got this problem, blah, 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 blah. And then you end up pulling together all of the knowledge you've got about the specifics of the system, the way the system is built, the architecture of the system. Then you start looking at things like networking, firewalls cause you more trouble. firewalls and routing cause more trouble, I think, than almost anything else in terms of failed deployments. Well, if you've got a home lab and it's Linux based, then you would have had a big leg up from the start anyway. And Docker is just, as you probably know, Docker is just a wrapper anyway. It's a sort of makes life easier for doing containers, and containers in essence are kind of like root jails. They're just a way of putting a process into a C group. So yeah. And the ability, I tell you what, the other thing with having a home lab is the ability to sort of come home and just poke things with a sharp stick and see what works and what doesn't work. We kind of got off what I was doing, but this is more interesting. So install Jenkins. Yeah, exactly. Yeah. A word of warning about this. I mean, I agree with you that being able to fire things up. I mean, like for example, the setup I'm using here on this server, Concourse is installed as Docker. It's their Dockerized version, and it's a simple compose. In fact, you can look at the script. I mean, it couldn't be more simple. He said, I mean, it literally is just a question of fetching the compose file and then running Docker compose, and I mean that's it, and that's great. But you wouldn't put that into a production environment. In actual fact, Concourse is quite difficult to deploy into a full size, a full production environment, and that's why a lot of people use things like GitHub. And here's the problem: your daily driver Linux, or just you? I tend to use Mac. My machine is a Mac. That's historical. I'll tell you the reason why. The reason I use a Mac was because you couldn't, for love nor money, you couldn't get hold of a decent Linux laptop. And so for many years, I used Mac laptops when I was working because they were closest thing. They were kind of Unix based. But I always run a VM with Linux on it for my daily driver. So all my work, with a few exceptions, is done inside virtual machines. In fact, even when I was working on Windows, we often would run Windows virtual machines inside Windows, and the reason we do that is because Windows infuriates me. It doesn't annoy me; it infuriates me. But the Windows VMs, the reason we used them was for the same reason that we now use containers a lot for build pipelines, and that is stability. What we found was, as PCs got more and more powerful, and you could sort of very easily have a 8 or 16 core machine with a 32 or 64 gig of RAM available for your developers, it was much easier to say to people, here's a virtual machine image of your development environment, which they could then use. And if they destroyed it, it was no big deal. You just said, oh, we'll just reset the virtual machine. And that way, it makes it a low-cost solution. Somebody comes on, if you want to onboard somebody, you just say, oh, here's the virtual machine image. You're already set up. You've got everything you need. All your licenses are sorted out. Your IDE is sorted out. Your project environment's all sorted out. You've got everything you need in order to be able to get on with the job. Whereas building a PC every time, we used to do ghosted images and things like that, but why would you do that now? Just run it as a VM. Particularly now, okay, because now the hypervisors connect straight through to the hardware anyway. So you might as well. Okay, most Type 2 hypervisors, well, all Type 2 hypervisors by definition, connect to the operating system. With Intel's, what is it, VXT, VTX? I can never remember. Yeah, the actual processor and things are readily available. So you don't really pay the cost you used to, because you used to pay a high cost with software emulation and things like that. But now, never touched a Mac. Yeah, filthy swine. VMware's pretty good as well. Yeah. I use VirtualBox. I've actually got VMware Desktop on this Mac, which I used for many years, and then I had some real problems with it. It was just a nightmare. This is going back about 5 or 6 years now, but I had so much trouble with it. I switched to VirtualBox, and I've got to admit, I just use VirtualBox now locally. But VMware Desktop was great. I haven't used it for a long time on the Mac. I think it's called Fusion on the Mac, or was. Yeah, the price point of VirtualBox certainly makes it very appealing. Mind you, I think no, Fusion was about 80 quid. So I mean, it's not exactly breaking the bank, but the VMware ESX stuff is good. And in actual fact, VMware, what was it they bought recently? Oh, Salt. They bought Salt Stack, which is my tool of choice for pretty much everything else: configuration management, monitoring, self-healing systems, all that kind of stuff. So I tend to use Salt a lot. Yeah. Have you actually got that on your home server? Actually, you talk about gaming on Linux. It's getting pretty good with the Steam stuff now. There are still issues, no doubt, but it's certainly a hell of a lot better than it was even 2 or 3 years ago. Cheat. It's not solving a problem efficiently is not cheating. Yeah, well, was it earlier this year? Nvidia finally said that they were going to do their drivers properly on Linux, which was always, the graphics cards were always a bugbear for Linux gaming. Not, I mean, I don't do much gaming, so it's kind of irrelevant. But yeah, and in actual fact, I've rigged up my old Mac with a Debian Linux install. And I've got a couple of old Lenovo laptops that I now run Linux on natively, but I tend to run them. I either run something like the Cube OS, or I run them in order that I can run VMs on them anyway. So Intel NUC and user. Yeah, I've got a couple of NUCs that I use as part of my setup. But again, I tend to just install, like, Debian server on them. Yeah, and I've got a mine's a QNAP NAS actually rather than Synology, but yeah, same basic idea. What? Don't look at me like that. Yeah, in actual fact, I was looking on eBay. You can buy some pretty tasty X Enterprise Dell machines now for a few £100. But mainly because everyone's going into the cloud, so of course they're selling off all their old on-prem systems. So you can actually pick up some pretty good, 1 or 2 U servers fairly cheaply. And you don't really need a massive amount of power. What was it? I think for about sort of 200-300 quid, you could get a system with I don't know, 8 core, 16 thread. More importantly, you can get it with like 128 gig of RAM, and a couple of terabytes of disk space. Admittedly, a hard disk rather than SSDs, but they're quite tasty for that kind of price point. I've actually been thinking about putting a couple in my rack myself. Yeah, well, that energy prices are a big problem because I was looking at these Dells and they're like, oh yeah, they've got two 700-watt redundant power supplies, which basically means you're looking at 700 watts of power. Admittedly, that'd be peak. So you're probably talking about 250 watts, an hour, which at what 40. What is it now? I don't know what mine's going up to. It's 33 at the moment. I suppose it will go up by. It'll go up to about 40, 45p, something like that. I don't know, an hour. So you're talking about 10p an hour to run your server. It's fine if it's only running for a couple of hours, but if you're running all day, every day, that mounts up. Plex for TV shows and movies. Yeah, I looked at Plex. I'm not a huge fan. I've actually just discovered I've been using an Apple TV for most of my media stuff, tied up to the NAS, and I've been using I used to use VLC, but now what have I just changed to it just recently. Anyway, but Plex is fine. Yeah, no, Jellyfin. I looked at Jellyfin, yeah, as an open source alternative to Plex, which is definitely a possibility. No, it's just a player, but it does all of the, it goes to the movie database and gets all the images and stuff. What the hell is it called? No, it's gone. It's just a player, but it does all of the sophisticated stuff on the front end. If you're gonna go down the road, I tell you what I do use a lot is I use a lot of Raspberry Pis, and they work really well with like Docker. And if you want to screw around with Kubernetes and stuff like that. Which is another technology that almost certainly you'll get asked about if you're going to go down the road of DevOps. And it's actually a bugbear. Yeah, well, I've actually got, okay, how many? 5, 6. I've got about a dozen Raspberry Pis kicking around, all from like Raspberry Pi 2s onwards. But they're kind of good because they're cheap, and even I mean, getting hold of them is a bit tricky now. But the decent ones anyway, the 4s with a decent amount of RAM. But they're great because they're very easy to screw around with. They're not overly powerful, but they're also really good for like building up little clusters and things like that, experimenting with. But if you've got a decent sized server and you're running VMs on it, it's basically the same thing nowadays. Anyway, it's kind of we've gone off the rails a bit. I mean, don't get me wrong, this is fun. Yeah, I think you said earlier you were going to be using Docker Swarm, and this is something that really bugs me about. If you read like on r/DevOps and stuff like that, people go, "Oh, you're going to be using Kubernetes." It's like that bollocks. You don't really. Docker Swarm is good for hundreds and if not thousands of containers. You'll be fine. Kubernetes is really it's a sort of 800-pound gorilla. Most people who use it don't really need it. You certainly don't need it if you're just going to run a few dozen containers. But there you go. Yeah, Proxmox. Yeah, well, that's what I was thinking about putting onto a fairly beefy server. You know, I was going to get a reasonably sized Dell server, stick a bunch of 20 terabyte disks in it, and build a Proxmox server and use that as the server. But you see, this is the problem. You see, I've got so much other kit lying around that I could use. I mean, I've got an old Mac Pro from 2007, maybe even earlier than that. That would be fine as a server. It's an Intel, so I could actually repurpose that as a server, and that's only 300 watts or so. And you don't need, redundant power supplies and things like that. So yeah. But yeah, I mean, to be honest, if you're going to spend money on a NUC, you might be as well, other than the power consumption issue, you might be as well looking at a server off eBay. You get more bang for your buck, but as you said, the power consumption might be an issue. NUCs, for all of their, relatively high cost, I think, that's just an opinion. Their power consumption is fairly low because they tend to use mobile processors to keep the thermals down more than anything. Going the Proxmox route's not a bad idea either, because quite a lot of the VM orchestration software, things like Puppet and Salt and stuff like that. Although maybe not Puppet. Salt Cloud certainly has a Proxmox provisioner. Terraform will have a Proxmox provisioner, and so you could actually use that to provision your VMs on your Proxmox. Much the way we're using Vagrant to provision this one here. It's all part of the magic of infrastructure as code. So I mean, it's something you really ought to think about if you're going to go down the Proxmox road. You ought to start thinking about it in those terms. I mean, I'm terrible at this because most of my stuff is cobbled together. But I do try for the important parts to actually write the infrastructure as code element to make sure all the deployments are repeatable. Because I've screwed up so often myself where I've forgotten how something was put together, and then I don't know, disk failure or something has wiped out the system. If it's all infrastructure as code, then who cares? You just rebuild it, and that's why we do things like this, where we put together pipelines to build the system, and then when you're doing the deployment, you've got all the provisioning stuff as well, which is sort of later on in this introductory course, where we talk about provisioning the VMs from scratch. So we do all the stuff like the cloud init files and things like that in order to build out cloud infrastructure. Because that's the other way of going, rather than investing in something like a NUC, is to use something like AWS, or my preferred one is DigitalOcean. And actually, if all you're wanting to do is build systems to try them out, then it's just as well to do it with a cloud system. You can build it, tear it down. And that has the advantage that you can actually build really quite big, sophisticated systems for your own testing purposes. But if you want stuff that's going to be running like Plex servers and stuff like that, then yeah, Azure as well. Yeah. The problem with things like Azure, AWS, and Google Cloud is that they can be very tricky. Any system that actually creates consultants who specialize in costing models, you've got to be a bit suspicious of. This is what always pissed me off about Microsoft back in the day. You actually have to employ someone who is a specialist in Microsoft licenses to figure out the most efficient way of buying licenses for your systems, which is, yeah, all that says to me is that the licensing model is deliberately obscure, you know. And I get the same vibe whenever I look at like AWS. Yeah, exactly. It is. It's exactly like and AWS is the same vibe. And it's you have these consultants now who will come in and tell you how to optimize your system to reduce the costs of your AWS infrastructure. It's like, if you need that kind of expertise, the model's too complicated, which is why whenever I'm talking to people about doing it, for themselves, I say use something like DigitalOcean, because you can just put £100 onto your DigitalOcean account as a prepay, and then when you run out, you get a warning that you've run out and you need to top up. But they don't just sort of like throw the baby out with the bathwater. They don't throw everything out. They give you a certain grace period to top up, or you can just realise that, oh shit, I left that server running that I didn't mean to. You can just tear it down. Or if you've got long-running servers, I have an account which runs things like a personal mail server and various other bits and bobs. And for that, I just have an ongoing charge to my account because I know that it's going to be so much a month. Because they have a very generous, I think it's 4 terabytes ingress and egress. Oh yeah. I tell you what, DigitalOcean's documentation is absolutely brilliant. Okay, almost any question you've got about setting up a Linux server, DigitalOcean will have a really, really good document that describes everything. Like if you want to set up your own email server, although DigitalOcean specifically say don't set up SMTP servers on them, and this is because of various problems with blacklisting and stuff like that. But basically, if you want to set something up on a Linux server, they've probably got a really good guide about how to do it. If you want to learn how to use network file tables, which is IP tables, but the new version, go and look at DigitalOcean. Their write-ups are usually pretty good. They're very clear and step by step. Yeah, I've got nothing but good things to say about DigitalOcean generally. Their uptime so far for me has been excellent over the last 6-7 years, something like that. And I've never had any real problems with them. They provide all the basics, which is all I need. They've been adding more and more services, which leads me to worry that they might end up going down the sort of AWS complicated road. But if all you want is a compute engine, a machine, spinning up a Linux server and using it as a web server, for example, to host, I don't know, your blog site or whatever, is dead simple, and their costing model is extremely straightforward. And like I said, they give you really very generous ingress and egress, which is where you get caught out with services like AWS. Because people go, oh, AWS, really cheap. And then you go, yeah, I know. And until you account for the cost of all of the data traveling to and from your servers, then it's not cheap. You suddenly realise that you've got to pay thousands of dollars to get your bloody data back out of their system. Anyway, not that that's necessarily a bad thing. It's just a something to be aware of when you're doing these things. Yeah, exactly. Yeah, it's very easy to do. Having said that, like I said, if you design stuff as your internet as code, and if you use a system like Salt, for example, one of the things you can do is have a scheduled teardown. So you can say things like, "Oh, right, every night at 7 o'clock, anything which is tagged with, temp, tear it down," and that way, the problem kind of goes away, because you can just have a local, only Raspberry Pi can do it, which basically will interact with DigitalOcean's API, and then every night you can tear down all your servers. I've not bothered doing it myself. I just keep an eye on things, and besides which, like I said, with a prepay, you know that there's a sort of cap where, if you put £100 on your account, then the most you're going to be charged is £100. And DigitalOcean are pretty good about it. I know a lot of people also go with Linode, which I believe has got a very similar kind of setup. But I've never used Linode, so I can't really comment. But I know a lot of people do use them. Yeah, well, I mean, if you want to run more Linux machines than you've got capacity for at home, and you don't have the energy costs, you know. So yeah, if you want to try your hand at deploying and running really big systems, then using a cloud service is definitely the way to go. I think I can't remember who did it now, but there was I mean, Google sponsored it, so the costs were covered by Google, but they ran out like 1 million machines in a few minutes. Using it was something like Salt or something like that, where they just ran up. Oh no, it was HashiCorp, and they were trying out Terraform, I think it was, and they wanted to know how efficient it was at spinning up systems. Was it HashiCorp Terraform, or was it Chef? I can't remember. But I mean, it was a proof of concept. It wasn't really a serious thing, but they spun out like something like 1 million machines in a few minutes. And again, it was all just done by massively concurrent processing. But yeah, well, I mean, in theory, Terraform is platform agnostic. In practice, it's not, but with a little bit of care and forethought, you can make most of your infrastructure agnostic. The real problem comes down when you're dealing with the cloud services is all of the sort of add-ons, things like the elastic load balancer and stuff like that with AWS. They all have their own terminology. But I mean, there are, meta abstractions that you can use, which will then translate between all the various platforms. There's a big debate about whether or not it's worthwhile trying to make your internet as code platform agnostic. My personally, my attitude is you should only make it dependent on a specific platform when you absolutely have to. So that's the reason why. Like I said, if you looked at the earlier parts of this, you'll notice that all of the if you look at the Vagrant file, all of the actual setup is abstracted into these scripts. And the reason for that is because by having this abstraction layer, you keep yourself as independent as possible from the underlying orchestration system. So in this case, Vagrant. Okay, so I can take those scripts and I can run them on any Debian server and it'll be fine. Puppet's the same sort of thing as Terraform. No, well, I don't know whether Puppet has actually got a cloud orchestration built in. Salt does. SaltStack does. It's got a thing called Salt Cloud, which is basically Terraform. The same kind of idea. The idea that you have provisioning of machines, which you then configuration manage using Salt. Terraform's the same kind of idea where you provision machines and there's an abstraction within Terraform. So you can abstract out the bit that does the setting up of the machine from the bit that does the configuration management of what goes on the machine. Puppet is a configuration manager that you tend to run on the machine once it's created. So it's the configuration manager. I don't know, it's been a long time since I used Puppet. I think I used Puppet 6-7 years ago. And back then it didn't have a cloud orchestration component. But it may do. It may do now. Puppet, powerful infrastructure automation, blah, blah, blah. Cloud and hybrid automation. So it looks like they do actually have. Yeah, so they've got integrations with things like AWS. So enterprise. Yeah, so it looks like Puppet does do some cloud orchestration stuff. And again, and this is something I try to stress to people who are learning things like DevOps is learn concepts rather than technologies. Technologies are easy, yeah, but here's the thing, Ginger Guy. It's if you learn the core idea, you can whenever you're learning anything, learn the core idea behind it, because the chances are that all the suppliers basically do the same thing. Yeah? And so if you know the core idea behind it, then learning the syntax. Here's an example, okay? You can use Python, Perl, Bash script, Go, Rust, Ruby, any of these languages. They all basically work the same way. If you understand the core ideas behind coding, then the rest of it is just syntax and libraries. Syntax, you have to know that Python is indent sensitive. You have to know that Go is statically typed. You have to know that Python's dynamically typed. But you don't need to relearn all of this stuff. Once you know the ideas behind it, they all basically work the same way. The rest of it is just syntax. Once you've learned the basics of networking, it makes it much easier then when somebody comes along and says, oh, I want you to configure a firewall. That's just a question of learning the syntax of the configuration or the user interface. And frankly, as a DevOps, if you're learning anything other than a command line or an API interface, you're probably wasting your time. All of these user interfaces are very sexy, but they're bloody useless from a DevOps perspective, because no, that's a bit unfair. They're not useless. They are. If you go to something like your AWS console or dashboard or whatever the fuck they call it, to create your virtual machine, that is a problem, because you have to use their interface, and that is necessarily manual. Okay, if you're using something like Terraform, or you're using just their API in a Bash script, that's better from the point of view of DevOps, because that's code. But again, so I got off the track slightly there. Yeah, learn the concepts, and there are certain key concepts, like for example abstraction, like for example coupling, cohesion. These are really core concepts that will serve you whether you're writing programs or developing architectures or thinking about tools for doing configuration management and DevOps. You learn the idea behind it before you learn the tool, or as you're learning the tool, try to map that back to these core ideas. Yeah, yeah, exactly. If you can do it through a basic shell interface, you're quids in. Yeah. Learn to use curl and wget, and interact with APIs through those. Write Bash scripts. Apart from anything else, personally, I learn a lot more by using the lower level stuff. Yeah. It's much easier for me. It's much easier to learn a new technology by actually poking it with a sharp stick and figuring out what's going on underneath. There's all the pretty stuff at the top is generally unimportant. That doesn't mean that visualization isn't important. You want to be able to do things like visualize in graphs and so on, time series data, and there's definitely a use for that kind of stuff. But you don't want to interact with your systems that way. Yeah, exactly. In actual fact, there's a really interesting project on GitHub that basically implements Docker as Bash scripts. And that's a really good demonstration of the fact that Docker, in essence, is actually just sort of a pretty front end to some very simple ideas that are actually baked into the Linux kernel. In fact, let's see if we can find it. I can't remember offhand what it was called. It was something like Docker in 100 lines of Bash or something stupid like that. No. No. This might be it. No. No. But it's something along these lines where it's basically just showing you that it's basically just showing you that it was just a bunch of, oh, hang on a minute, here we go, Docker implementing there around 100 lines of Bash. Here we go. This is the one. Docker. There you go. But I mean, just reading this script will teach you a lot more about what Docker is and what it does, and about shell scripting, than, for example, spending ages reading a book on writing shell scripts. And that's the value of these things. And again, once you know the basics of yeah, okay, let's just take a look at this. I haven't actually looked at this in any great detail, but okay, so you can see here, you've got things like function declaration, although these are slightly redundant, but whatever. So you can see it's basically function definitions. Okay, there's a curl running in a sub-process, which then gets put inside this string. And you see a lot of this kind of stuff. There you go. So this is the Docker pull. And you can see all it does is it curls stuff from the repository. Does a bit of magic text manipulation. That's where it actually gets, yeah, that's where it actually downloads it and then expands it for each layer. Anyway, exercise for the student, as it were. But like I said, just working through something like that, you'll learn a hell of a lot more. It'll give you a bit of brain ache, don't get me wrong. It's not a straightforward thing to understand. But for me, that's the way I learn stuff, is by, as I say, poking it with a sharp stick. I mean, I'm currently in the process of working through an architecture for something that I've got in mind, and I want to do single sign-on. So I'm having to learn about Keycloak, because I want to use Keycloak as the identity system and the authorization system within the single sign-on system. So I'm looking at that. And so every time I look at another piece of technology that I want to interface with it, I'm looking whether it actually complies with the OIDC, which is the open standard, which Keycloak is one of the standards that Keycloak implements. So you know, so I'm looking at that, and I want to put a wiki on there, and I want to put a micro blogging service. So I'm looking at all of these things and thinking, okay, so you know, does Mastodon, which is an open source microblogger, does that support single sign-on using something like Keycloak? Yes, it does. Does the Media Wiki? Yes, it does. So you know, it's all good stuff, and it's just fun to play with. I do have the luxury now that, you know, because I don't have a full-time job, I can screw around with this stuff as much as I like. But the downside to having time to play with these things is that I very rarely get things done, because I tend to spend so much time playing around with stuff that it's very easy to sort of say, you know, mañana. Which is the reason why I try to give myself sort of projects to do. Enjoying yourself? Anyway, yes, yeah, lots of things to learn. You, as I said to you, you will never stop learning new stuff. You just and the other thing is, people worry about not knowing enough, and you don't need to know everything. You just need to know enough to not look stupid. A lot of my job when I was working was actually interfacing between the various groups. So as the sort of DevOps role, you'd have network specialists and security specialists and software developers, and all of these people talk slightly different language. And it was very easy, particularly when you're talking about the interface between operations and development. It's very easy to find that there's a miscommunication. So one of the big skills of DevOps people is this ability to translate and interface between the groups. So in order to do that, you just have to know enough that you don't sound like a complete clown when you're talking to them. So when you're talking to a network person, you don't need to know the ins and outs of every aspect of networking. That's their job. But you do need to know enough about, for example, I don't know. You need to know about, for example, the TCP/IP stack. You need to know the difference between TCP and UDP and what the implications of that are. But you don't need to know all of the ins and outs. You don't need to know massive amounts of detail. Same goes with things like firewalls. You need to know enough to be able to spot the problem, as it were. But you don't really need to know massive amounts of detail. You leave that to a specialist, somebody who actually does it all the time, especially with things that are around the sort of security of your system. It's very easy to screw it up. Reading other people's code is educational for a number of reasons. One, you get good, well-written code and you get badly written code. Being able to tell the difference is a key skill. More than anything, because if you're onboarding stuff, and you're trying to integrate it into your system, what you don't want to do is adopt badly written code. Sometimes you can't help it because you're just told that's what we're going to be, and that's the worst. That is the worst when you're told, no, we're going to be using product X, and if you know that product X is the wrong tool, it can be extremely frustrating. I just broke it. But those are the things we have to live with. Bash scripting, coding partners and other stuff. Use other people's code. Yeah, absolutely. There's an old joke. What is it? When you do it, it's plagiarism. When I do it, it's research. And I'm a big believer in stealing other people's code, but don't make the mistake of stealing other people's code without understanding it. It's very easy to get yourself into a lot of trouble. I think I talked about this on the very first one of these streams, where it's a famous one. There was a GitHub repository, okay, and in this GitHub repository, there was a project called pad left. I think it was called pad left. And all it did was it padded a string, and I can't remember whether it left filled it with spaces or left filled it with zeros. But anyway, it basically padded the string to a fixed width. It's like 2 lines of JavaScript. It was nothing. It was a stupid little tiny thing. The problem was that loads of people had integrated this into their CI pipeline directly. Okay, so they were actually pulling the project directly from this particular GitHub repository. Why? I don't know. But anyway, they were. What happened was the guy who had this project had a falling out with various people and shut down his entire set of repositories, all the stuff he was on GitHub. So he shut his account down effectively. Pad left went with it, and this broke thousands of CI pipelines because all of a sudden they were getting errors because they couldn't pull this particular project from from GitHub. And people were like, "Oh, this is totally unreasonable." And my response was, "Well, you're a bloody idiot. You shouldn't be using things like that directly. If you're using something from GitHub in your CI pipeline and it's not yours, then you're a bloody idiot." Okay, what you should be doing at the very minimum is you should be creating your own fork of whatever you wanted to produce and then use your fork of it. Because at least then, if the original upstream goes tits up, yours is still stable. It still exists. So at the very least, you should create your own local fork. And I think I talked about this in an earlier stream about creating your own proxy artifact repositories and stuff like that. And it astonishes me how many organizations, even now, don't proxy their repositories. I've got to admit I'm guilty of this as well, but then there are good reasons. But so, for example, if you do something like this, if you want to install, if you do this, I don't know. I'm not even sure there is a NeoVim. Yeah, but if I did something like that, yeah, okay, I'm not going to actually do it. Okay, the problem with that is that is actually coming from a remote repository, the Debian repository as it happens, and it's not under my control. Okay, none of these packages are under my control. These are all packages supplied from a remote repository that's not under my control, which is fine. But what if they update these packages and I don't mean to get the updates? I just want the existing ones. I've not fixed anything in here. It's just going to get the latest ones. What if they decide to deprecate those packages, remove them from their repository? Again, it will break my systems if I try to do this and it's not there anymore. If I set up a proxy in between, a caching proxy in between, that means that when I go out to the remote repository, it will pull these packages into my proxy copy and then source from my proxy copy for all subsequent. Okay, this has a number of effects. In a large organization, it means that the bandwidth going out to the internet is obviously reduced because the thousands of machines that I'm using are not constantly going out to external sources. And as we discussed, things like AWS that can mount up really quickly. If my proxy's on the local network within AWS, I don't get charged for any bandwidth I use talking to that. Again, these are all things you have to think about when you're working on these systems. But more importantly, it means it's stable. That proxy repository is actually under my control. I hope that's making sense. But you see what I mean about these are the subtle things that you have to think about. And if you understand these things, and if you set these things up, you will be in the top 10% of organizations. Because most organizations don't do this. Most organizations will just rely on whatever GitHub happens to be available. They will rely on whatever, whatever Maven repositories they're using, or whatever app repositories, or Yum, or DNF, or whatever the latest thing is. So just that one concept of never relying on an external repository for your stable copy will save you. Oh yeah. Your point about copying stuff and installing stuff on Linux, yes, absolutely. But only do it once you understand what the thing is doing. Otherwise, A, you've learned nothing, and B, you won't be able to reproduce it. The third thing I'll say is when you're copying commands to install stuff on Linux, stick it in a script because you're going to forget what you did. And then you'll be doing what I do, which is hunt around on the internet going, oh, where the hell did I find those instructions? What was I doing? Stick it in a script, run the script rather than running the command directly. That way You know, things like this. Okay, these fly commands are fairly straightforward, but the number of times that you have to put them in, stick them in the script, because that way, even if you want to run that command, you know, on its own, I can just copy and paste it from the script, rather than trying to remember. Okay, I know it's -t main. I know it's set pipeline. Now, what are the parameters? It's there. It's in my script already. I don't need to remember it. And more importantly, I can just run the whole script and it does the job that I wanted it to do in the first place. Make sure you know what you're, yeah, absolutely. Yeah, it's more than just knowing what you want to install. It's also knowing, you know, what the command does. For example, here, what does the non-interactive flag do on that command? What does pipeline do on that command? Yeah, what's the config referring to on that command? You need to understand, yeah, what does -t stand for? I've been a bit naughty because I've used the short form, and generally, unless it's something you do a lot, using the short flags is a hiding to nothing. -t is an exception because you always have to put the target on there. Anyway, that's a whole other story. Yeah, but knowing these things, yeah. If you look at the Vagrant files, if you look at the installation scripts, even with standard packages, yeah, I've just put that line in to a script. Okay, so I know it's going to be reproducible. I don't have to remember what did I do last time. It's there, done. It can go into my Git repository. You know, I'm finished. Yeah, GitLab, you'll probably end up installing in at least 2 containers because there'll be a database. But yeah, and you can certainly put GitLab in locally. There you go, GitLab Docker images. So the answer is yes, you can. You can also, look, you can put it into Kubernetes as well. And I mean, you know, Docker's not witchcraft. I mean, at the end of the day, it's just a way of running processes. It's not. I mean, sure, okay, Docker takes care of things like network isolation and stuff like that, and it definitely makes life easier. But again, if you understand what it's doing, yeah, if you understand what it's doing, even if it's only conceptually what it's doing, it's much easier then to understand what the hell you're looking at. Yeah, what does all this witchcraft actually mean? Well, as long as you understand pretty much, yeah, exactly. Yes, exactly. Yeah, you're absolutely right. Just defining, just being able to say, okay, I understand the difference between an image and the running container. I understand about port mapping. I understand about volumes. I understand about you know, the layered file system and why it exists. What are the benefits? Why is that a good thing? The layered file system is really important to understand from the point of view of developing efficient images as well, because most images you look at are absolute dog shit. Yeah. There's a tool, and Avzar, who was here last week, he remembered what it was. I couldn't remember, but it's called Dive. Yeah, so this Dive tool is brilliant. And if you're doing any CI chain which is building Docker images, you want to be using Dive because It has two modes. One mode is a sort of UI. I can inspect the internals of a Docker image. The other one is it basically gives you a go no go decision on your image. Is it efficient? Yeah. Is it efficiently sized? Yeah. Well, Docker. You see, again, Docker networks, in particular, that it makes life a lot easier with Docker networks. If you actually look at what it's doing underneath as well, because that's an education about things like the way IP tables works. Or, okay, IP tables is the old way of referring to it. We really ought to get used to calling it NFT. It's the net filter tables on Linux. And being able to look at those and work out what is Docker set up. Yeah, so when you set up a Docker bridge network, go and have a look at the IP tables that it creates and the way it works, and try to understand what is actually done in order to isolate your network or to bridge it onto your host network. Again, it's a good way of learning not only Docker and understanding the subtle differences between the various network layers within Docker, but also it's a good way of learning what's going on the operating system itself. So, when you use the bridge network driver on Docker, what does it actually do on the host? How does it work? It's just another thing for you to. Again, you don't need to understand all of the detail. You just need to understand the principle. Yeah. I hope you're happy because I'm uncomfortable. You want to get out? Go on then. No? Do. Are you getting down or not? Yeah, binds and volumes. Yeah, a lot of people get confused by that. I don't know why. It's not that complicated. And again, volumes. Volumes is a bit of hand wavy stuff. Because volumes are, without oversimplifying, volumes are just fancy predefined binds. I mean, there is a subtle difference, but in essence, because when you go and actually look at them, actually on the file system, all they are is layered file system on the host file system. So they just happen to be put into a special location. Sprocket. Oh, I assume was he a Jack Russell? Or you're a menace, aren't you? What is it? It's not good looking at me like that. Oh, right. Oh, well, he'd be slightly, yeah, okay. Sprocket would be slightly bigger than, slightly bigger than Kenny. What was his name? Oh, blimey, two, bloody hell. No, one Jack Russell is more than enough for me, aren't you? You can be a handful. And you don't like German Shepherds, do you? Now then, you're going to settle down? Or are you going to continue to be a pain? Anyway, well, it's been a fun conversation. I'm not going to lie, it wasn't what I'd actually planned on, but it's actually probably been more interesting than what I had planned. The general idea taking this forward is to get this to the point where we can put more jobs in the pipeline to set up an environment, which will actually set up another pipeline. We'll set up another pipeline to set up the environment, and then we'll deploy into that environment, and we'll set up versioning and a proper repository. I might do that in the week actually, and then just do a show and tell. Get it all up and running quickly, because one of the things I did note is GitLab, the cloud version, does actually have a package repository system here. Okay, and that package registry has an API which is fairly readily accessible from the command line. So one of the things we can do is use that to write a resource, something like this, because we've got they've got one for GitHub. Where are we? GitHub. Here we go. So they've got one for GitHub releases, which is a similar idea. So we could actually steal that, and we could use this to create a similar thing for GitLab. I did actually have a quick look, and I couldn't see anything. Right. Yeah, there's a GitLab flow, but merge request, which is probably oh, wait a minute, this is a delivery pipeline. French isn't good enough to understand that, so we'll skip that. Merge request, GitLab secrets. Oh, there you go. This is a Docker file to build a GitLab image. Interesting. Intriguing. Not exactly sophisticated, but anyway, not what I was looking for. GitLab release resource. Fetches and creates versioned GitLab releases. Probably not what I do though. That could actually be it. Yeah. Okay. Actually, this could be. I might steal this. This looks like it's 90% of the way there, and you'll notice it's written in Go. And this is my point about if you learn the basics, because I don't know Go particularly well, but I bet with a few minutes of study, I can probably work out basically how this works. Because again, it's okay. So it's a function. And if I was going to guess, I would say that was the return type. That's the name of the function. And those are the parameters. Having said that, we've got tag name. And, oh, no, maybe those are the return. Ah. Oh, no, 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 no. This is probably what it applies to. Okay. That's the GitLab client. This creates a new GitLab. So yes, so that's the return type, and obviously it it returns a tuple of some description, isn't it? Yeah. So that's returning a pointer to the GitLab, and then nil for the error. And this is when it returns. And I gather from the brief things I'd looked at that this is pretty much go pro forma. You almost see this almost every one, the way it returns the error, which kind of makes a fucking nonsense of doing it, really, isn't it? Anyway, okay, so it goes function name. Okay, so what's the first part? Is that how you add things to? My guess would be that this is the way you add methods to the class, not a type structure. But again, I want to guess. And it looks like that's probably what it does. Hmm. Yeah, anyway, that's something to look at later. The main thing is I think that does pretty much what I want, which is it has this resource. So we can then use the GitLab packaging system as our artifact repository for the toolchain. So after it's run the unit test, we can create a zip file or a tar file containing our unit tested site, and then that can be put into the release. It's fairly straightforward. Yep. Okay. I'll do that. I'll do that offline because otherwise it will just be me staring at the screen, creased forehead for half an hour. What? Do you want to go out? Is that what this is all about? Hmm. Oh, I suppose we better call it a night, haven't we? Hmm. Given that we've sort of gone off the rails a bit. Yeah, good luck with your course. I hope that it pays off for you. Are you job hunting on the basis of getting this course certification or whatever? Go on, you. Off you get for 5 minutes. Yeah, I know. Oh, you do want to go out. Go on then. Yeah, yeah. The prejudice seems to be in the US that DevOps. You need to do your dev or your ops first. I'm not sure that's true in the UK. I see a lot of people say, no, no, no. I got into DevOps from day one. And to be perfectly honest, there's such a skill shortage at the moment that as long as you've got realistic expectations. The other route you might want to try is working for one of the consultancy firms, and getting them to provide you as a bum on a seat. And the reason I say that is because you might get more a broader mix of experience. Yeah, it depends on your particular way your mind works. I freelanced for many years, and I liked the fact that I would be there for 3 months, although sometimes I was there for a couple of years. But in theory, I was there for sort of 3 months, 6 months, sort things out, get it all set up, move on to another job, and I liked that. Now I started freelancing after I'd been a permie for about 6 years, but another route that achieve the same kind of thing would have been to actually go and work for one of the consultancies. Because again, you're working for them and they will put you in as a bum on a seat. Yeah, exactly. But the thing is, well, yeah, and that was always the bummer about freelancing, was the fact that I spent almost I was almost never home during the week. Yeah, so you live at home for the weekend and then go and live in rented accommodation or whatever during the week, which is a bit of a bummer. Do you know what? It always gripped me about the whole working remote thing. I think only one job. There was only one job where I would say I had to actually be on site, and the only reason for that was it was a secure establishment, and therefore it was physically a secure environment. But almost everywhere else, I not only could I work remotely, but I often did remote work remotely on the basis that they wanted me to log in to fix some crap that had gone wrong, and amazingly I could then work remotely. But other than that, they were like, no, you've got to be in the office. It's like, why? 90% of my job involves sitting at a terminal, typing code in. Why do I need to travel to London or whatever? But there you go. Anyway, I'll wish you the best of luck with your thing tomorrow and with your job hunting. For the rest of people, hopefully I'll get back to business as usual next week. Yes, I know you're there. Oh, you're a bloody nuisance. Yes, I know you're there. I'll let you out in a minute. Yes, right, okay. I'm gonna call it a night. Like I say, normal service will be resumed next week, and we'll pick this whole thing up